Alright, so this first section of 4-7 Day 3 is going to be a review of the two factoring concepts that we've already done from the previous lessons. So this first two questions are going to be solving by, factoring by pulling out the greatest common factor. So the biggest thing you can divide out of each of those, and we put it out front. And then these 3 through 6 are going to be the ones where we came up with the factors of the last term that add to get the middle, because we just have a or a front coefficient here of the squared term that's 1. So we can do that split the middle method. So go ahead and try that. All of those on your own. Good practice. You need to have factoring mastered. So we're just doing a little bit in each lesson at a time. So practice those and then check when you're ready. All right, so go ahead and look through and double check your answers with the ones that I have posted there. Make sure to note any of those that you may need to practice more. So these are just the basic factoring, and it's going to get a little bit harder. So make sure that you are practicing factoring. There's plenty of websites. Ask me for extra sheets, but you really need to be practicing factoring and make sure you've got that mastered quickly. All right, let's move on to our stretches and compressions. So this part is the I would say more difficult part. So I would take some notes if you're not used to that. Following along, taking some notes, pausing as you go as needed. So we're just going to go ahead and first look at when we have a 2 out front, a vertical stretch, and then we're going to look and see what happens when we have a 1/2 or a vertical compression. So this first part is just the parent function here on the left. So if I take and plug these values in for x and I actually square them, what would I get? Well, -3 squared is 9. That'll fit in there. There, it kind of does. All right, the next one is -2 squared, which is 4. Next one is -1 squared, which is 1. So this is just that parent function. Those perfect squares. 0 squared is 0. And then it repeats. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So the coordinates of that, and it's actually kind of backwards, here's my x, here's my output when I plugged in x squared, or technically I should have put -3 squared, but I just put the solution there. So our ordered pair would be if I plug in -3, then my output is 9. So input is your x, output is your y. So it's -3, 9. Down here it was +3, 9. Then it is plugging in -2 and you get 4. And then down here plugging in +2 and we get 4, and so forth. So we're just plugging these values in on this side until we get our parent function, which is actually already graphed down here. So what happens on this side when we actually take and we plug in our values for x? We plug them into the function 2x squared. So we would wind up with, and I'm going to go ahead and write these out. So it is 2 times -3 squared. So we want to make sure that we are doing the -3 squared first and then timesing it by 2 to figure out what our output would be. Oops, didn't want that. So if we plug -3 in, we get -3 squared, which is 9, 9 times 2, which is 18. So my output here is 18. Or if you notice, it's twice the output of the parent function, because we had 9 over here. Well, here we have 18 because it's 2x squared. So it's twice as large. So next we're going to plug in -2. And we take -2 and square it, and we get 4, and then we would multiply that by 2, the number in front, to get 8. So it looks like when I plug in my ordered pair, -2, I'd get 8 as the output. So go ahead and fill the rest of those in, and then I'll have them posted here in just a second. All right, so there's our table all filled in. Again, plugging these values in for the x here for 2x squared, and then what our ordered pair would be. So let's see where y values are on this side What compared to the parent function y values? Well, they were double, or you could say greater. Let's just go ahead and say greater in general. But in this case specifically, they are double. So if we were to graph these points here, we would start at 0, 0, and just plot that one first, and then 1, 2, so go to 1, go up 1, 2, and then we would go to 2, and we'd go to 8. So notice instead of 1, 1, we go up twice as much. Instead of 2, 4, we go up to 8. We go twice as much. And then for 3, instead of 9, we would go up to 18. So then 4 here, instead of going to 16, we would end up at 32. And then we would do it on the other side here. So plotting these coordinates here, negative 1, 2, negative 2, 8. Oops. I think I marked it wrong on this side. There we go. And then we'd have 3, 18. And then we draw our parabola. Yours is probably going to be prettier than mine. There we go. So, same thing over here. All these values are going to be the same because it's the parent function. So I'm just going to go ahead and copy these. And just bring them over. Nope, missed 0, 0. All right, so there's our parent function. Again, it's already graphed. So next, what we're going to do, and actually that should be 1/2, not 2 anymore. So there we go. So we're going to plug it into 1/2 x squared. So plugging in negative 3, we would take negative 3 squared and then take it times that half. So what our points would wind up being, and now I'm just going to bring this over, is if we plug in negative 3, we would wind up with 4.5, because we'd wind up with negative 3 squared, which is 9, and half of 9 is 4.5. So we're just plugging in these x values into the function above there. So continuing to plug those in, we would plug in negative 2, and we would get 2. We would plug in negative 1, and we would get 0.5, or 1/2 if you wanted to keep it as a fraction. Plug in 0, and you would get 0. So 0, 0. And then you would plug in 1, and you would get 0.5. And you would plug in 2, and you would get 2. And then you'd plug in 3, and you'd get 4.5. So let's go ahead and plot those points. But notice that our y values here are less, or are half, the values of our parent function. All right, so these values were half the values of the original parent function. So let's go ahead and graph those, starting with 0, 0. So we've already got that one. 1, and then we go to just a half, and then 2 goes to 2, half the amount that you would be there. Here you're going to go to 4.5, again half the amount that you would have there, and then here instead of going to 16, you would go to 8, half the amount. So it would be kind of looking like that on that side. And then we do the same thing over here, half, and then here we go to 2, and then here we would go to 4.5, and then here we would go to 8. And there it is. So this one to the right here is our compression, kind of pressing it down, and then here is our stretch, kind of pulling it up like that silly putty. So let's go ahead and practice some of these. We'll do the first 2 together, then I'll have you do the next 2 on your own. So let's take a look at that first one. So we want to graph 3x squared. So basically what that is saying is that it's going to be 3 times the amount that you would normally graph. So instead of at 1, we would start at 3. So instead of 1, 1, it'd be 1, 3. So again, 3 times the amount. So this next one is normally it's at 4, but 3 times that amount would be 12, which in a sense would be off the graph up here. So we would graph 3 times that amount, which is stretching it, and that's what our graph would look like. And you could make a table off to the side and pick some values if you wanted to, but the sooner you memorize the fact that if it's a stretch, it's going to be pretty skinny, and then if it's a compression over here, we'll see that example in a second, but it's going to be kind of pressed down more wide. So this, we're going to put vertical stretch by 3. And then let's graph the other one over here. So again, we're half the amount that we would be. So instead of 1, we're going to be at a half. Instead of 4, we're going to be at 2. Instead of 9, we're going to be at 4.5. And so forth and so on. So we would go and draw our parabola. Again, half. Here, instead of 4, we'd be at 2, half that amount. Instead of 9, we'd be at 4.5. And then we draw our parabola. And this is a vertical compression because it is a fraction. So it's vertical because it's out front. It's a compression because it is less than, that number is a half. It's less than 1. So try these next two on your own. Again, look at the examples above if you need to, and then push play when you're ready to check. All right, so with number 3, when it's 1/4, if you're going to be at 1, you're really only at a fourth, and that's kind of hard to graph. But if you're at 2, you're a fourth of 4, which would be just 1. And then if can't really graph that one very nicely, it'd be 9/4, which is kind of hard to graph. So let's move on to 4. If we were at 4, we would go up to 16. But instead of being at 16, we're a fourth of that, which a fourth of 16 is 4. So 4 would be our next point. So think of it as being a fourth of where you'd normally be. And that is a vertical compression by 1/4. For number 4, we have a stretch. It's vertical stretch by 2, as well as a reflection, that negative, so that turns it upside down. So we're going to be twice as big, or twice as high up in this sense. So here, instead of 1, we're going to be up 2. Instead of going up 4 for the next one, we would go up 8. So it'd be twice as kind of steep. So notice it's being stretched, skinnier. All right, so what we're going to do is identify what's happening here. So let's look at the kind of slope in a sense. Instead of at 1, we're up 3. So that means, and it's skinny like that, so it's being stretched, which means it's a big number. So f of x is equaling, and since it was at a 3 instead of normally like it's at a 1 here, it's up 3. It's 3 times the amount that it normally is. So it would be a 3x squared, which is a vertical stretch. All right, the next one, notice that it's a compression. The red line is the one that we're looking at, and it's a compression, so we know it's going to be a fraction. So we look to see how much. Well, at 2, we're at 1. At 4, we're at 4. So what that is that is half the amount that we'd normally be, because at 2, we should be at 4. Sorry, at 2, we should be at 4, but we're at 1, excuse me. At 4, we should be at 16, but we're at 4. Sorry, so that is 1/4 of the amount that we should be at. So we should have a 1/4 x squared. Got to look at those points. All right, next, let's take a look at a couple of examples here. So we're going to go ahead and write the vertex. We're going to write the axis of symmetry, and we're going to write what happened. This is a review of stuff that you've done before, but it just has some stretches in there for you to try. So I'd really like for you to practice those on your own and then push play to check. Same thing down here. I want you to try this on your own, stretch or compression. Pretty easy, just look in front. And then down here, putting it back into, so this is all stuff that you've done before, so I really want you to try and practice these things on your own, and then I'll go through them once you hit play again. All right, so our vertex is going to be the opposite of the inside and the number outside, so starting there, we don't have any stretches or compressions, so it just moved us right 1 and up 2. Over here, we would start at 0, -3. It is a reflection, and then we want to make sure that our slope is double what it normally be. So instead of 1, we'd go up 2, and then we'd go up 8 from there instead of 4. So we moved down 3. It was a reflection over the x-axis, and it was a vertical stretch by 2. over here opposite of the inside, and then the number outside. So -3, -6 is where you start.